Alright, looks like we're alive. Hey everybody. Alright, let's see if we can make this an interesting one. We're starting to get into the difficult jobs now. I've done all the easy ones. Now I'm actually going to have to start thinking, and that's going to hurt. Thinking is exercise for the brain, and that, yeah, like all things, if you don't use it when you start exercising it, it can be a little bit painful. So looks like we're going to be doing that. Beep. Radio. Job underway. This is a very Jim Hook type laptop, but it's not from Jim. But I'm sure he could appreciate that one. I remember when it came in, I was like, Jim would like to see this one. Edbos, Drucker, Neo, Martina, Antonio, Teresa, Slime. Wait, Slime's here. Good to see you, Slime. Sort of used to seeing you on in the Discord, of course, but not necessarily out here in the Wild West. Okay, so this is a drop T on my Mac a month ago. Only just saved up a little money. Oh right, now they want to try and get data off it. Not a good idea spilling things on these machines, but if it does happen, then hey, you do kind of want to. It's not going to be a repair the machine situation, most likely. I'm just hoping that it hasn't done too much damage. If we're very, very, very lucky, if the odds are in our favor, we may just have a bad lid angle sensor. However, I do believe this one might have gone through the keyboard, in which case we're in a lot of trouble. Hey creature, hey Clebo, hey Jan Zimmy, Miles. I mean, obviously, I sort of use the brain a lot when I'm doing programming, but this sort of stuff, it's a different area of the brain. So it's like you spend all your life working on your legs, and then all of a sudden you got to use your arms, and it still hurts. Obviously, I am not a professor, by the way. I'm not even close. I'm not even a postgrad. Ach, yeah, man. Alright, so it's coming through the back. You can tell from these marks here, so it's drawn it in through here. Backlight is completely gone. I'm kind of curious to see if lid angle sensor is gone. If we're lucky, we may have missed the most critical parts. I mean, we can do the recovery without a backlight. That's not a big problem. With the lid angle sensors, I almost... no, now we've got a problem. That's a big problem. Alright. The question is, how far did that one go? So when you get liquid damage, the most ideal thing for you to do is just turn off the machine and have someone who is suitably qualified as quickly as possible disconnect the battery. Because even if you just drop the lid and hope for the best, it's going to keep chewing away. And this one has been chewing away. So we're going to be depending very heavily on this one, that hopefully they have set up external display on this one. If they haven't set up external display, then this is not going to be a cheap recovery, if at all possible. The reason why it's not a cheap recovery if they don't have display is because if we want to re-establish backlight, the backlight controller chips are not cheap on these. They're not like the LP8550s from the earlier days. These ones are actually expensive. They've gotten better lately, but they're still expensive. Let's see, we want T6. Scratch the nose, why not? Oh, wrong ones. Think these are 22. Yeah, I'm fairly sure these are 22. Or maybe 21. Trying to think what model. Yeah, 2021. This is an M1. What? What do you... Oh, great. It's lifting its own screw out. Trying to work out what's going on here because I don't think it's been opened before, yet it has lots of weirdness going on about it. So I'm not sure whether I'm misreading it, which I probably am. On the upside, the HDMI section has not been touched, so if it has got external display enabled, then we should be able to get an image. So who's going to be the new drama maker? You know, it's all gone a bit quiet now, and I'm kind of bored. It's funny how when you don't like the drama, but then when it's gone, you're kind of like, oh, now it's no drama. I'm only kidding. Shouldn't really stir up drama, but it can be fun. It's always fun if you're not the victim. It's not how you spell Q, Miles. It's Q-U-E. Oh, sorry, C-U-E. You gotta spell it C-U-E. Or did the Americans go and steal that one, break that one as well? Like center and center. Center of something versus the center of something. Check and check. Money check or check something. So many ambiguities. Hey Pierre. Teresa. Come on. Bit of fun. Besides, it gets me subscribers. And remember, I need subscribers because I'm not successful. If he is watching this, he'll be like, that's not what I meant. And so, yes it was. Takes so long to get these machines apart. Really. If you ever send one of these in and you get a sort of a extra labor charge, it's because of this. Yeah, they're just absolute take forever machines. Actually, all this new activity going around has reminded me that I've got a couple of GPUs that I've got to send back to the people. I had some people who sent me a few, like 3090s and things like that, just for me to try and, see if I could do anything with them. And when they offered, I was like, it isn't really my thing. I can try, but there's no guarantees, and I just haven't had the time. So it's time for me to send those things back. And it wasn't due to lack of support or anything. I had a lot of people offering me, if I needed help, just give them a call or whatever. But I just didn't have the room to set up or anything. It was, oh God. I have a horrible feeling about this one. This is quite extensive. So we've got here, 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 here. Under the PMIC. By the slave PMIC. By the ISL. It's sort of like hitting all the wrong places. And of course, yeah, the trackpad's completely jacked. All we can really do in this sort of scenario is we clean up best as we can, and then we take it from there, see what comes up. I will have to remove that trackpad connector. It will probably be fused into the ground, so it might be a couple of layers of digging for us to clear that. I believe it was T. Oh, yep, T. It was T. Let's see if we have that. Okay, short on the PP bus. Okay, yep. Rather strong short on PP bus, and that will predominantly be this trackpad situation. So we'll tackle that first, see if that clears the short, then at least we can deal with the other damage and see if we can find our way around. So this is what happens, is it starts burning itself up. There's a massive amount of power on tap in this area, and this is a unfortunately fairly regular event. Certainly got serious down there, started to melt this flex even. The tricky part here, I mean, I'm not too worried about this keyboard connector or anything else like that. The tricky part is that a lot of those pins, they are going to actually be welded. So we're going to be trying to get the connector up, but at the same time, it's, like I said, it's welded to the board. And so it makes it quite hard to get that connector up without excessively heating up everything else. So I'm just going to try and manually debride this. This is all just like soft stuff. Get the worst out of the way. Grab the Dremel. You know, it's probably not the worst suggestion, apart from the fact that I'll probably give myself silicosis or something like that. Okay, it's definitely gone through a couple of layers of board there. Ooh, yeah. So once I can get that connector off, then I can start digging. And if we're lucky, we may actually get to the bottom of the short before it goes into critical areas. But I have a bad feeling. This is probably the worst I've dealt with. Just gonna grab myself a couple of metal shields. No, this is trackpad. I'm not too worried about the battery connector. Easy enough to put another one back on, and also most likely we'll run this from MagSafe 3 anyway. The depth of that damage is very concerning. Hey, Rilla. I'm not even going to try and be nice to this connector. Yeah, normally I'm always trying to practice my skills and minimize the amount of damage to get a connector up, but I'm not worried about it this time around. Well, it's a robust connector, that's for sure. Nothing's even beginning to move yet. Front's come up. That's what I hate. Oh, that's the battery data connector. Could be worse. Now, the first thing that's concerned is that there's puffing going on up here. Not so much on this side, but certainly like this area here is all puffed up. Hey James Ewing, Golden Badger. No, didn't forget Avilla. Just hands are full. Let's see. 0.7. Alright, now the fun part starts. The debriding. Unfortunately, there's no real pleasant or easy way to do this. You just have to get in and start peeling it back. need to really change my blade. This one's a bit old, bit blunt, and it's got a unwanted hook on the end. The cause of the short usually is all this black gunk that you can see coming out. Yeah, I've got to get another blade. I can't do my little carving circuits without it. Some people prefer to use those motorized grinding tools. I'm not really a fan of that option. Yeah, I prefer the fixed blade. I find the trouble with the motorized tools is sometimes you can get a little carried away with them, and before you know it, you've kind of gone a little bit too far. Kind of thinking I might remove these various mount points. Hopefully they come up without too much trouble. Usually they do. The other way is you stick a soldering iron down them with a bunch of solder in it. One. Ruining my damn battery connector. Two. Three. Four. Yeah, I'm definitely not touching fiberglass pens, thank you very much. Other people can, that's up to them. I choose not to. Half the problem when you are debriding these areas actually is the excess of fiberglass that gets up and over the place. Whoosh, it's a hot board now. Okay. Oh boy, this is deep. And you've got to excavate it at an angle like this so that the adjacent or the layers above each other or don't end up shorting each other out. Yeah, this is going a long way. That's messy. No, the blade does the job. The blade does the job. It's not my first rodeo with these. And I don't want it to be fast. This is definitely not where you want speed. You just want to take your time. We're going to be getting close to the other side of the board now. They're usually around about 12 layers, I think, 12 to 16. And you can see that it's just more and more of that carbon black. This has been going for quite some time. It's just getting worse as I go. Probably still going to read pretty heavily shorter because those layers are actually crashing into each other. So you're going to start getting carbon on carbon. Copper on copper. Looks like 126, we've still got some issues in there. 126 is still a bit much. So at this point I'll try and clean it, give it nice sort of smooth. So we don't run into any layer, ground layers crashing into the other layer. Hey Joey. but we really need to see, 700, 800 ohms. You see, the trouble is if I power it up like this, and if there is a little bit of a short in there, okay, now we've got it cleared. That's cleared. Yeah, if I try to power it up while it's still got a little bit of short there, then it will just carry on running again, and it will make our recovery job harder once more. What a mess. See if we can dry brush this. Kiwi, usually this sort of thing is pretty expensive, but we'll see how we go. If we're lucky and it still ends up working, even if it's a limited, as long as we get a path to data, if we can get a path to data without having to resort to more complicated processes, then we can stick with sort of around about the standard price. Jeez. Funnily enough, the backlight controller didn't get touched, but everything around it did. All right. The thing that really scares me is if you have a situation where you've just got a little bit of junk and it's sitting on a feedback pair, a divider. And so it kind of looks okay, everything measures okay statically, but then when you fire it up, because the feedback's being messed with, you go from, instead of having 2 volts into the chip, it says, oh, you wanted 20 volts, sure, and it kills it. Hello there, Noor Sairi from Malaysia, not too far from here. Well, they came real close to the ISL. I don't know what those things do, but they're probably knocked out, that's for sure. This is the liquid, sorry, not the liquid, the slightly water tainted alcohol, so it's 80-20, and then I finish up with some 100%. Yeah. See, like, this is a good example actually. See, it's bridging across this current sensor, and that means then the current sensor amplifier here is going to have a bad reading, and so when it, something burned up there, so it's not going to know if it's exceeding its threshold or anything like that. It's just going to keep pumping, And that's usually what will happen when you have junk going across your shunts like that, is that they will actually underread. And so you don't actually have a safety cutout anymore. Because when 10 amps is flowing, it's going to read, oh, there's only 1 amp flowing. I'm being a little bit dramatic there, but that's akin to what would happen. So I may actually see how we go with this. There's a lot of things that you can get away with in terms of liquid damage, but when it comes to don't be the anti. Hope this is not one of the security chips. Just give it a little bit of time to soak it. Now normally I would dry brush, but this tea has kind of solidified in a way that dry brushing just isn't going to do anything. So I have to go in with the 80-20. Hey Sleepwalker. Hey Henosis. Oh, naturally the speaker section got wiped out. Well, actually it can't be too bad because it's not shorted. Although it may quickly become so. Good on you, mate. Good on ya. Hey, man Anning. Oh, sorry, Mark Anning. I don't know why I said man Anning. Sorry, Mark. Seems like every time I think I'm nearly finished, I find something new. Alright, I think we're potentially ready to try. I can actually plug it in to the HDMI on this one. I'll get my MagSafe 3. So that is the nice thing about these new machines, is that with the MagSafe 3 you can run them directly. You don't have to have a battery. Miles, which damn cap are you talking about? You're talking about the one that was on the, what do you call it? On the speaker section? You're talking about this one up here, I know you are. I know you are. It just seemed like it had been chewing away in the liquid. That's fine, 600-700. Yep, I knew the one you were talking about. So I would focus on this area, see if it goes up in flames. Hey, Catherine. Let's see, would you like me to focus the microscope on that area? Actually, I can't. Well, rather, I don't want to. See, above plus auxiliary. I'm just gonna. I'll zoom in for you. Okay? How's that sound? There you go. All right. Well, not much else we can do, but oh, it does help if I plug this one in. We ready for this? Umberto Ragon? Whatever, we're not doing a countdown, we're just going for it. Nothing coming up anyway. I'll try USB-C, but I doubt that's going to change anything. I can't smell any pop. No, nothing. In a way, that's actually quite problematic. We're not even getting negotiation, which means the SoC or the M1 is quite likely dead. Yeah, I certainly didn't hear any pops, squawks, or anything of the sort. That's the hole where it's emerging from. Ah, flippin' hell, how did I miss all that? Ah. Anyway. That was bad of me to miss that. Don't know how I did that, but I did. So let's get that cleaned up. But I am somewhat expecting that this whole thing has long since died. But we're going to keep trying. Yeah, hard to pop things at only 20 milliamp. And there wasn't a spike that I could see. I didn't see a 20-volt spike, nothing. That's why it's handy having that USB-C meter graph, because you can go, okay, well, let's look retrospectively at the board. And at the behavior, and see if there is a massive spike. That just looks like it's just, yeah, that's just milky tea. Okay, I might have to rip out these. Yeah, I really did miss a lot of things. Wow, that's bad. That's what I get for talking to you guys. I miss things. 230 milliamp, but it was at 5 volts, so it's still very small. It's barely 1 watt. You can't even make a 201 pop with such a short amount of energy. I wonder if that's shorted though. That kind of looks a bit iffy. No. No. Okay. Okay, we're going to lift this up. Check to see if any misdeeds have... So easy to almost get the SOC on that. Yeah, a bit of junk there. That can definitely stop it. I've had to do that repair a few times. I think I need some assistance here. We'll lift up this one as well. Okay, no problem there. Am I a Kiwi? No, I'm definitely Australian. I just have a bit of a mangled accent. Most people, when they think of Australian, they feel most comfortable or most at home with the way that, say, Dave Jones talks. That's pretty much the presumed standard of Australian speech, and I do not fit into that. And of course Dave comes from a different era and from a different location to myself. What the hell is that chip? Can't say I've seen one of those before. Interesting. I am, yes, that is correct with regards to the age. Oh, now don't call me Steve Irwin Electronics, my goodness. No, wait, you're talking about Dave Jones. Yeah, Dave Jones is Steve Irwin of Electronics. Yeah, we just got that initial spike, which is not really meaningful. Alright, this is going to be fun. Probably should have cleaned that up. Half the problem is you're trying to avoid cleaning up more than you have to. You kind of want to get it working and not fiddle-faddle with anything that you don't have to. The other problem we have here, of course, is that while the PP bus may not be shorted, it's not to say that there isn't something else shorted down there. What a mess. Yes, it does look like a geology project or a open pit mine. Open pit mine done by drunk drivers. That's correct. Almost looked like it was thinking then, but changed its mind. What bothers me is we're not even getting just the basic, we're not even getting any sort of current flow to begin the negotiation. I mean, okay, we've got 15 milliamps or whatever, goodness knows what that's going to. It certainly has turned out to be not just a lit angle sensor, eh? Kind of hoped it would be, but I should have known better. Oops. Yeah, creature, most likely it will be somewhere very obscure. I'll try on the right hand side port, just in case something is meddling with those ports, but I doubt it. It's worth a shot though. Yeah, we get that 313 momentarily and then it just goes away, and it's far too quick and it doesn't repeat, which is a problem. If it was repeating at 313, then yeah, that we'd be able to find that. But the fact that it doesn't repeat is a problem. Hey Harold. Oh, I did get your details, Harold. I just been running around like an idiot lately. We already chewed up almost all of our time for tonight too. So this could be another dead end. Okay, I'm going to peel off these big stickers. Might find something under here. I have my doubts, but we're going to do it anyway. Yeah, nothing much. See, the thing is, the tea, its viscosity tends to mean that it won't usually breach between those gaps very easily. I mean, it can do it if you put enough there, but the surface tension of the tea will tend to just make it run around it. It's not a crack, it's a hair. Yes, there's a missing signal. The trouble is, the terrifying thing can be that it might be passing through that trackpad area. Just going to go along and take all of these things off. So what I'm going to be doing now, after this is all taken off, is we go back over the areas that have been hit with corrosion and we start looking for components that have, well, specifically resistors in most cases. Like, I'd be inclined to replace that current sensor. I'm a little worried about the fact that these two test pads are missing, although in this case it shouldn't be a problem. Basically because they are the high and low outputs for this resistor. But in this case they don't run off anywhere. Yeah, it's just something to keep in mind of. But yeah, I'd be interested in replacing that current sensor. There's not really anything over here. This is the HDMI. And even if all this is shorted out, we should still get our 20 volt negotiation. That's the problem. We just don't even get our 20 volt negotiation. It's not really even trying, which is problematic mentally for me because of the fact that there really is no damage in this area. Yeah, this is all your CD3217s and such, and there's no real damage in that area, which means it's probably working fine. And because the rest of the protocol, the rest of the negotiation stuff tends to happen in here, from what I recall, that's not a good thing. It was just tea, Steve. Yeah. Reverse side. Yeah, I'm dreaming. Yeah, 3 V8 on's probably what I should be checking for, I think. Because it might be being generated, but then it gets lost because of the cut through the trackpad area. So 2100. It's time to start the voltage diagnostics. What a pain. So it doesn't look like it goes through, but it probably does. I mean, it's just everywhere. Yeah, Joey, go ahead. Of course you can ask. And here we go. I wonder if that is the 3V8. Yeah, that is. How on earth a fuse can partially blow instead of the whole... Wow. Oh yeah, that happens. Actually, Creature might be able to answer that. But yeah, I've had it happen quite a few times. If it's sort of just marginal, where it starts to melt, but it doesn't quite get there. But yeah, it happens. You had a 30k fuse. Wow. Okay, that beats mine. Mine was about 22 ohms, and it was on an A1466. And on the one side, you'd have 8.6 volts. No, not 8.6. You have 12. Oh no, it was, yeah, 8 volts on one side and then about 5 volts on the other. And I was like, that's interesting. $5 volt, yeah, that sounds about right to me. Sounds like you got a winner there. Okay, just plug in the USB-C and see if we can get 3V8. Oops. Voltage. And microscope. Haha. At least you found it, Joey. At least you found it. Oh, that's probably not a good look. Oh, that's a terrible look. I don't think we're supposed to have 12.3 on that side. Schematics. Oh no, PPV in. Okay, no, that's cool. Alright, that's fine. My bad. I was panicking. Have you ever thought of putting FlexBV in a repository like Chocolate Scoop, or is that too much technical? Yeah, I don't even know. I'm fine. Oh, do you mean just in terms of like the free version or something like that? I'm just fine just sharing it out like I do now. It's much easier for me if I keep it in a centralized location. It's these caps up the top. Yeah, we say always test the fuse first, and then how many of us forget to do that? 0.7. Alright, looks like we can hone in on something here. Let's check our continuity, or rather let's check our resistance. Okay, it looks fine, so basically yeah, we're not generating 3V8. R5823 burn, not sure, I'll have a look. Can one of these super detailed PDF board views be converted to no. The style of information that is in PDFs is not the kind of information that we require in order to be able to have a board view. At least there's no practical way that I can think of at this point, based on what I know of what's in those PDFs, to reliably generate a board view. The other problem is that with those particular files, so the trouble with PDF is that it's kind of like, you know, when you get ransom notes and they make them by cutting out letters and stuff like that from magazines and sticking them together. Well, that's often quite what PDFs are like. They're this mosaic of they call them runes. It's a mosaic of runes, and there's no inferred correlation between the runes other than the fact that you may have them together as a string or as a paragraph at best, but they don't have a correlation or connection to imagery around them or anything like that. So when you see a resistor on a schematic with a value next to it and things like that, there's no actual real way of knowing that the text around it is referring to that resistor. Bloody hell, these things are hard to get off. No, don't destroy the... I'm gonna burn my fingers. Got a smidge of flux there for heat transfer. I mean, don't get me wrong, I do constantly look around and see if I'm missing something when it comes to the PDFs, because it is definitely... Ouch, ouch, ouch. It's definitely something that's been bugging me for a very long time that I wish I could sort out. If nothing else, to permit me to be able to quickly generate OB data. Like if I knew that the runes for a resistance preceded or immediately succeeded the drawing of a resistor at a position nearby, then yeah, I mean, I'd be really trying to... Oh my goodness, come on. This needs a lot of preheat, so I'm just going to go around and warm everything up. That is not coming up in a hurry. That one at least is gone. Okay, other shit's melting now. Okay, I'm just gonna have to sacrifice those caps. Yep, just heard it then. Oh, stinks bad too. Disgusting. The board file information is created from an export from the original design file. So what they do is they have their original design file in something like OrCAD or whatever they were using, and then the BRD file is generated from an export of that. I don't know, Creature, I reckon we could reuse that shunt. It'll just have a slightly different value. Alright. See, the problem I have here right now is there's nothing really wrong with this circuit area. Maybe the only thing could be a missing an enable line. Anyway, I wanted to have a look at that current regular, the shunt, because it did have a fair bit of junk on it. Okay. So you can check some continuities. Trouble is, Creature, if I move that pop cap, I'm going to pop another one. It's got that cascade effect. Okay, 2K. Open, not surprised. Should be open, yeah. This should be open. Yep. That may not have been the issue at all on here, but like I said, it was mucked up with junk that I wanted to do it. Yeah, one thing I'm finding I have to be a little bit more strict with is the what do you call it? not feature creep, that's not what I'm trying to think of. It's similar to feature creep, and I don't know why my brain's not letting me answer this right now. Scope creep, that's what I'm after. Yeah, scope creep. So what's happening at the moment is that Flexboard View is becoming more known and popular, and there's a lot of push to move it into new areas, and we refer to that as scope creep. So yeah, it's slowly moving, and people are trying to make it wick over into areas that it's not designed for. And there's some degree of scope creep that you can tolerate and that you can relatively easily bridge across to. But eventually you get to the point where you've reached the architectural design limit of the software in its ability to be able to stretch out like that. And if you go any further, you're then faced with a fairly extensive rework. Now, as an example of that, Flexboard View, we were able to give it new file formats like XZZ and stuff like that. But the next thing that a lot of people are pushing for is to have multi-layers. And in order to go to multi-layers, I kind of have to redesign the internal rendering system a bit. And by a bit, I mean a lot. But yeah, so you have to be careful of managing feature scope creep, because otherwise you can end up with a completely useless piece of software. Why the yeah, that's interesting. That is interesting because the light stayed on. Hey, Sotterbridge. Yeah, I don't think there's a full Gerber stack for these. We're just lucky to get the board file. There are some GenCAD ones coming out. I actually haven't looked at the internal data of the GenCAD versions, whether to see they have layers or not. But this is another example of what I'm talking about. At some point I have to deal with this, and it may be that it becomes Flexboard View version 6, because it is a big jump to do that sort of thing. And people are like, why don't you just stack the layers? It's not that hard. And you can kind of do that in a sort of a bodgy kind of way, and it sort of works. But the trouble is, it messes you up. You kind of hit a wall, and you kind of kludged your way to that, rather than having a proper solution. Oh, thank you, Dragon. Oh, Damraz, thank you for the 15. This is you've paid your entertainment. Okay, so we need another one of these shunts. Wait for OBV to do it. Ooh. That will cause a lot of mischief. I think half the time that is why the development on OBV has basically ground to a standstill, because the people developing it are like, we don't want to do this because Paul's just going to steal our stuff. And I mean, they're not wrong, because it is legal. It's all within the license, the MIT license, to do so. But it's a little bit of a slap in the face if they are thinking that, given that we just invested a lot of money into decoding XCZ, and then TiVo View will be coming up. So I'm throwing a lot of stuff that normally I would keep, you would normally keep locked up in your commercial software, and I'm throwing it out there. Plus we're running OB data and all the other stuff. So it's a little bit like a bit on the nose if they did do that. Damn it, we need that shunt. People are distracting me. But like I said, I can understand their concerns, but they're a little bit unfounded. About the only thing that I'm looking for are file formats. File format specifications. Open Board View and Flexboard View have diverged so severely now. Okay, so 1 milliohm, 612, they should be everywhere. The trouble with that shunt creature is that it's an input to feed the 3v8, and so I'm worried that if it's misreading, it's just immediately shutting itself down. I actually wouldn't be surprised if I had tested before I pulled those parts off. I wouldn't have been surprised if we would see the 3v8 come up momentarily. Okay, 1041. I'll take that one. Hello, Lullo. Okay, R5400. Also in a bit of a gnarly spot. $1041? No. Are you 1041? I think you are. Yeah, okay, we've got it here. Now, if I'm really lucky, it will also have the same shunt. Worst case scenario, I'll just take the 3v8. It should be on the 3v8 section as well. I didn't look to see what is the shunt that we need. 190A3 RSW. Okay, that's going to be a little bit trickier to find. I think I might have some actually. INA 190A3. INA 190s. You do have to be careful with these. I've got them here. I do have them. I've bought them in the past for this sort of thing. Let's get the shunt across first and then we can chase the actual chip. Front source, the easiest way if you sort of indirectly want to do it is you do it for OBV. So like if you do a file format thing with OBV, then like if I know what the format is there and what's going on, I can rewrite it. And yeah, rewriting file formats is not a big issue. Or parsing, I should rather say. If that's what, yeah, is it a file format you're referring to? I mean, it's just sort of like, it comes with the territory, I guess, with commercial software. And I am not opening up the source, as in, I'm not letting the source get out of this workshop, basically. It's not that I don't trust some people. Yeah, there's certainly some people I've been interested in sharing the source with. It's more a case of the universe has a horrible way of completely and utterly making the worst things happen. Of which I mean, oops, suddenly the source gets out there. Is the word for OBV disingenuous? Yeah, no, Tony, that's actually very much the... You read my mind there. Good job. Well done. I was going to say that, but I thought, no, maybe I'm being a bit harsh there. Yeah, they've got a different set of policies, different set of things that they're planning on doing, I guess. I try to help where I can without getting in their way. Like I said, with the XZZ, it's like, well, here you go, here's the file format for it. And I know that Rob Brown has got OB data parser for it as well, but I don't know if he has... Sorry, I was just checking something. I don't know if he's submitted it as a PR yet or not. I don't know if any of you have noticed, but down the bottom here we now actually have what's on the clipboard. And then, you got this is our location, things like this. So, the status bar indicates a few new things. Oh, the 2016 has it. Yeah. Yeah, Francis, when those sort of situations occur, it is crap, and I agree. I do agree. Like, one of the things I try to do is, I do make sure I'm always within the confines of the license. I go above and beyond as much as I can for that. So there's been a number of times where I could have taken a easy path for something because it was in GPL format, and I just can't touch that stuff because it contaminates the rest of my code, and of course it's not legal. But so I just stick with MIT, Apache, BSD3, all that sort of stuff. The sort of what I'm talking about. So if it's legal, it's legal, and I'm in. But if it's GPL, then I don't touch it. I don't want to while I have my own views on things regarding licenses, I am not going to overrule someone else's request. Well, I got a crash log? That's cool. Okay, UD 550, just erase crash logs and ignore. Okay, so this is our chip. Oh, bastard. It looks like someone already took that chip. Filthy pirate bastards. There we go, there it is there. And we're going to pop those caps. So whether I believe in the GPL license or not is irrelevant. If it's GPL, then it's not for me. It's like, I'm not going to go and cut-paste that code and leave off the GPL header. I have seen plenty of people do that, and I've got to say, I know that has been I know that has been done. Sorry. Actually, it hasn't been done, but I know there's been some violations, and I don't want to talk about it, but I am talking about it, aren't I? But realistically, I suppose in this case it's a situation of, it's not a major thing. Not with my stuff though. Microscope. But yeah, people taking GPL code and then compiling it into commercial code, that's not on. Yay, did you hear that? That's a cap going bang. These are terrible for it. They just do it on a... There, another... Oh, it's popcorn! That's why you have an extractor, folks. Dropping frames, quite possible. Oh shit. Which one's pin 1? I'm going to assume the one on the... Oh no. God damn it. I hate these chips. They're like, okay, one of us is pin 1. You're like, yep, real useful. So we've got 3 marks. Now I'm going to assume this is pin 1 up here and there, and they should match. And they do not. They are. Oh, that was interesting. There's pin 1 there. You can see the extra length and the slightly beveled edge. So that's pin 1. That could have been exciting. And by exciting, I mean terrifying. This flux runs away a little bit quicker than I like. It just means I've got to use more flux. It's very nice flux, but it does get vanquished. Okay. Yeah, as long as the text is the same way, I guess. But that's really weird, because now the text is technically upside down. But I don't know, what do you think, Creature? Because, you know, as far as I was concerned, the matching of the pads was the priority there. Text was upside down originally? Okay. Yep, thank you for that. Very confusing, because like, you could think, oh, that's pin 1, or is that... Yeah, anyway. Thank you, I appreciate that. This has been most helpful. Alright, so what we're going to do, I'm just going to see if there's a break in the 3v8 line. So like, we're going to measure here, and we're going to see if we can pick 3v8 up over here. Now, it's not a guarantee, but it's a start. So schematics, okay, so we've got there, and we'll check over here, because this bridges across. Okay, we've got this little cap here at the bottom of the speakers. Don't forget the caps. Which caps are you talking about? Actually. Yeah, there. Got it. Oh, the popcorn ones, yeah, I'm not worried about them right now. I just want to see if we can get 3v8. That cap that popped is a on the input side, so we're a little more tolerant of that. Okay, that's connected. So yeah, we do have 3v8 there, so traversing the board. Yeah, so it is going from like, where is it? Yeah, from here to here, all okay. Okay, but we're still not getting 3v8, probably. And we're kind of getting a little late now, so we may have to leave this. At least it's on the millivolt scale rather than higher. .3, we're good on the input, so it is getting across that shunt. We're just not getting anything generated. Oh, that's what I wanted to check. I wanted to see if it's got the enable on. Ah, where's my schematic? Okay, 5700. Ah. So we're looking for an enable line here. And probably wouldn't hurt to look at vSense. Current monitoring, fault, clock data. Ah, here we go. 5710. Interesting, that comes out of the ISL, it seems. I can just see that pin. Thank you, Krellin. Looks like you got your message out just as I found it. Sorry. Okay, enable is active there, but maybe it is not getting over here. So let's see. Yeah, 5200. Yeah, so it's the sort of middle-ish one. Okay, yeah, I see it. It's 0 ohms, so it doesn't matter what side I touch it. Alright, there's our problem. We don't have an enable line. So even though it's been emitted from the ISL, we're not getting it on this side. So it could be a line that has been cut. So what we have to do is run a trace from that little dot over to that resistor. Now I'm going to go and do micros insulin and we'll come back and do that. Oops. I need to get my box of wire. Where are you? There you go. Okie doke. So we've just got to see. Oh, we really do not have many options here. So it's just that. Because we can't get under there. And that's the only other place it appears, so yeah. It's going to be fun. Hey Chris, Greg, hey Jason, again. Jason, I've got one of your machines. I'm trying to think what I was meant to be asking you about. We're going to use some .01, is it? No, 0.1, so 1/10 of a millimeter. It's a little thick, but we kind of want something that's durable enough to get from one side to the other. Sounds like a bunch of crap going on outside. Probably wouldn't hurt for us to pre-tin this either, particularly on the ISL side. Yeah, that's not much to work with. What the? Why are you vibrating? Sorry folks, for some reason I've set up a... Oh, that's why. That's better. So we don't want to stuff this one up. With a hairy tip. Now, realistically, it probably would have been better for me to start on the other side with the resistor, because if for some reason I accidentally snag this, then this is very likely to just rip clean out. For the moment, for security, I'm actually going to tack it onto that other pad as well, just like that. We will remove that later, but for now not. Alright, some tape. I just want to sort of hold it down while I traverse it across. And then later on we will use UV cure to actually seal it in. But initially we just want to be able to, you know, put it down in some various places. There really isn't a good path for this to follow, I'm afraid. And I didn't want it too close to the front edge because it's a little bit too easy to get scuffed or snagged by various things going on over there. So that's, yeah, the lesser of two evils. Come on. That's fake soldered. At this point you're just sort of trying to break the insulation that's around that wire. I'm just going to bring out the rorter tip. It gives a bit more heat. Kind of shuffle this around so I can get it down flat. Okay. It is messy and it is ugly, I concur. But at this point, those are not really primary considerations. And of course now we're back here and we're going to need to cut that trace. What are we talking about? GPL violations? What did I miss? Or are you just referring to what we were talking about before, Francis? Someone's made a mess. Let's redo that. Bit of extra flux. I would definitely consider this to be quite precarious. Even just the process of cutting this wire gives me the heebie-jeebies right now, because if I get that stress going onto that little tiny pad top, the VIA, or the little miniature test pad, then it could have, you know, just torn it from its stalk. Okay, I think that's good. So what do we think? We're going to have success, or is it just going to be a womp womp? I guess we kind of want to look at the great hole there, see if anything happens to that. Predictions? Any? None? Don't care? All of the above. Wagner signal. Oh, good on you, creature. So we've got flashbang in the hole, smoke, same thing, yeah. $5 if it works. Oh, Slime's throwing his money down. Wumpa for it. Wump, wump, wump. Alright, I think we've got enough options here. Should probably wear my safety glasses just in case. Draco has confidence. Well, that's very nice of you, Draco. Of course, the question is, what are we actually after here? Are we after the 20 volts, or are we after a full working system? So, you know, we can debate that one. Here we go. It's trying, but it's not there yet. We'll try MagSafe 3. Actually, we'll see if we do have 3V8. It's definitely trying, but it's running into something else. Okay, we don't quite have 3V8. It's very erratic, so it feels like there's a feedback issue. So it is at least now enabled, but it's not getting the right kind of, yeah, it's not quite working. Yep, your money's safe. Alright. Well, unfortunately, I'm going to have to leave it at that because it is getting late. We're already at 10:30, and that is definitely my curfew, because what happens after 10:30, particularly on a job like this, is that you start to get a little fuzzy in the mind. You start making mistakes. You go, oh, I think I see where that pin is, and you make mistakes that could be critical. So I'm just going to leave this and deal with it tomorrow. But thank you all for watching. At least we're sort of moving slightly in the right direction. As for what could be causing 3V8 to fail at this point, we'll have to see. The current 270, it could be at this point now running into some other portion of the circuit that is actually short-circuited. Not sure if we have a... Actually, we'll just check to see if we have a way to isolate 3V8. I don't think we do, but... So schematics... Actually, what? Yeah, we can't really isolate it because we've got this sense shunt, and there's nothing after that. So what would have been nice is if there was another 0 ohm resistor or some sort of shunt on this side here. Actually, it says 3V8A on reg, so that might actually have a let's see, control right click. No. It goes straight to, it's just aliased, so it goes straight from Aeon Reg to Aeon rather than going through a shunt. It's just an alias. Oh well, we'll deal with it tomorrow. So it's the best I can offer for tonight. Wasn't exactly as successful as we were last night, but I guess we can't have that every night, even though I wish we could. It's just the way it goes. So thank you all for watching. I'll see you maybe tomorrow. Until then, you take care. I'll catch you later.